Hi guys, I have just returned with more circuit problem. Here is a circuit in the screen, and we have not been given that much of information, but we can work with what we have to find out all the missing variables. I'm sure that we will be at some point in this circuit be required to calculate the reading on A1 and also the reading on A2 and also the reading on R, resistance R, as well as the EMF. Because what we know in this circuit is what the resistance of the parallel circuit, and then we also know this resistance is 20 ohms. We don't know this resistance is just R, and then we also do not know the EMF of the battery, and also the voltage reading. We also do not know it. So the terminal voltage, we also do not know it. So we can see the switch S is closed. The switch H is closed. Terminal voltage is also referred to as the V load. So the first question requires us to state Ohm's law. The first question of this circuit, it says state Ohm's law. 2 marks just to state Ohm's law. It says that potential difference across a conductor this is potential difference across a conductor is directly proportional to the current flowing through a conductor, provided the temperature is constant. So that the question was worth 2 marks. The 2 marks just for stating Ohm's law. You have to write Ohm's law in words, in full words. I'm just writing this mathematical relationship because I have already stated Ohm's law or written Ohm's law in my very first video. Excuse me. And then we also have got 4.2. Question 4.2. As you can see in the screen, I'm sure the question paper is there of this electrical circuit. Requires us to find the reading on A1. We have to find the reading on A1. Okay, now let us find what we know. The reading on A1. I can find, so the total current passing through A1. As you can see, look at where A1 is. We've got here is A1, and then here it is, here is A1, and then some of the current passing through here, and then some of the current passes through here. And then here we can find the voltage of this current. We can find the voltage of this current, of this resistor. Then we know that the voltage of this resistor, 8 ohms, is the same as the voltage of this resistor, 16 ohms resistor. So we can find the voltage of that 8 ohm resistor. V 8 ohm resistor will be given by I. We know the current passing through that resistor, and the 8 ohm current, resistor, times times resistance. Resistance is of course 8 ohms. Then we have got V. The voltage is given by, I can just write a voltage let me just write the 8 ohms. The voltage of 8 ohm resistor is given by the current. The current is 0.5 times times 8. 0.5 times 8, that is just about half, and is given by 4 volts. So the voltage passing through here is 4 volts. I want to find the reading of A1 because I know that what happened to the current passing through A1, it was divided among this resistor and this resistor. So that is what we have. And then as we can also proceed to find this current passing through that resistor. The formula for current, you can just say I 16 amperes is equals to V, which is the voltage. The voltage is the same. Voltage here is the voltage is 4 volts, and here is 4 volts. So the voltage is the same. And then we have got V I is equal to V over R. So it will be given by voltage is 4. The voltage is 4. Resistance is 16. So I think that is about. Let us just verify the answer. We've got 4 divided by I think it's 0.25 divided by 16. So it's about a quarter. So it is the current is 0.25 amperes. The current passing through here is 0.25 amperes. Now to find the reading on A1, current A1 we'll have to add the true current, the one already given, is what? Reading on current passing through 8 ohm resistor plus current passing through 16 ohm resistor, which is equals to what? 0.5 amperes plus 0. What? 0.25 0.25 resistor. I think that would be given by 0.75 amperes. So that's what we have. The reading on ammeter A1 is 0.25. We have got the reading on ammeter A1 is equals to what? 0.25. So that is what we have. The reading on ammeter A1 is equals to 0.25. 0.75. So we are solving this circuit this way. I'm sure now if we have to find R, we will be able to, we know that this current is also the current passing through the 20 ohm. The next question requires us to find the reading on ammeter A2. It's a very, very interesting question with 5 marks. Very interesting. If the power dissipated by this resistor is what? It's a 12 watts. Remember, power is measured in 12 watts. We want to find the current passing through A2. This is the ammeter. Remember that. And then also, I can already conclude that the power is given by 12 watts, and is given by power can be given by IV. Power can be given by IV. So that is what we have. Now, as we proceed, we also have got what? I want to find the voltage passing through this component. I want to find the voltage passing through this component, because this is what I'm missing. I'm missing the voltage here, because if the power has been given to us 12 watts. So, and then the power has been given as 12 watts. I'm missing the what? The voltage. And then I want to find the voltage of this parallel section. And I know that the voltage of here is 4 watts. It's 4 watts. It's 4 watts. The voltage is 4 watts. Now I want to find the voltage of this 20 ohm resistor. After finding that voltage, I will add the two voltages together. I'm going to add the two voltages together. And then after adding the two voltages together, I will know that the voltage is given by what? The two voltages have been successfully added. So I will add the two voltages. And then what we have here, we have got what? We have got in the two voltages, what we have? We have the current. So 20 ohm resistor, the voltage passing through the 20 ohm resistor is given by V. 20 ohm resistor. Let me write that so that you can clearly see. 20 ohm resistor is given by I times R. The current is 0.75 times. What about the resistance? Is 20 ohm. Now we've got 0.75. 0.75 times 20 is given by 15. The voltage is 15 volts. So the voltage here passing through this is 15 volts. And now when we add the two, V, the voltage there, that is V load. That is the total voltage being used by the external resistance. V load will be given by 4 volts plus 15 volts, which equals to 90 volts. So that is what we have. Very interesting. So we know that all this connection, this resistors are parallel with this resistance. So it is what? A parallel connection. So since they are parallel, we can still proceed. We can also find the what? We can find since the resistors are parallel, we can find we know that it's 19. We know that the voltage will also be 19 since they are parallel. Then V is also equals to 19. The voltage I have been looking for is 19 volts. Now I want to find the reading on A1. It's going to be from this formula. IA is what? A2 will be given by power. What is power? Our power is 12, or let me just also write in terms of variables, equals to P over V, and in this case we get 12 divided by 19. 12 divided by 19. So as we proceed, we've got 12 divided by what? 19. What is the answer? Is 0.63 amperes. So the voltage is 0.63. So the current, the reading is 0.63 amperes. And also, if we add the two, we can also be able to find the what? To find the total current. Total current here is, with the current is 0.75 plus 0.63, that is the total current. And also, since we know the current passing through here, we can also find the reading on resistor R. The last question, which is 4.4, requires us to find the what? We need to find the reading on voltmeter V when switch S is open. Very interesting question. Switch S is opened. And that reading, the question, they say the reading on voltmeter V when switch S is open. I have just opened the switch. What is that reading? It is EMF. They are telling you to calculate EMF without saying the word EMF. So you have to know that the total voltage from the battery when the switch is what? Is open, or when there is no current flowing. And I've just calculated the total current in the circuit by adding the two current here. Here the current was 0.3 amperes, and I just added the two, and then I got 1.38. Sorry about that. I just got 1.38. So the total current in the circuit is 1.38 watt amperes. And then I have the total current, and I know that the voltage is flowing to the external circuit as we previously calculated. Voltage is what? V load is V load is 19. V load is equals to 19 volts. So we added the 15 we got here, and then the 4. So the 4 we got here, and the other 15. So, and then EMF, the one they want, is equals to V load plus V internal. V internal is equals to the current I R. The current is 1.38 amperes. The small letter r, internal resistance, is given by 1 amperes. So internal resistance is given by 1 amperes. And then let us proceed here. It says EMF is given by 19 volts plus 1.38 times what? Times 1, which is equals to 20.38 volts. So it is worth 3 months and very straightforward. So the EMF is 20.38 volts. So thank you for watching this video. I will also send one more last video to help us deal with electricity problem. Until next time.